This is a lecture on 8-4 z-test for a proportion. At this point, I'm under assumption that you are aware of the process of hypothesis testing. If you need review, please revisit 8.1 and 8.2. This test is a test for inference about population proportion. We have a new test. It is called the one proportion z-test. It has a new test statistic where the z is given to me at a p hat minus p divided by the square root of pq over n. This is the formula that is programmed into your calculator under the one proportion z-test. The p hat is the x over n. It is a binomial setting, so I'm going to write down assumptions in a second. And P is the population proportion, N is a sample size. This is your test statistic. In order to perform the z-test for a proportion, you have to follow the following assumptions. First, it has to be a random sample. This one will be assumed for all of the problems in this book. 2, this is a binomial experiment. So all of the assumptions of a binomial experiment must be met, meaning you asked a yes or no question, and the response is basically divided into two pieces. The responses are independent of one another, so the assumptions of a binomial experiment must be met. Now, back from chapter 6, we know that the binomial experiment or binomial distribution can be well approximated using a normal distribution if your n is large enough. The n is large enough must meet the conditions np has to be greater than or equal to 5 and nq has to be greater than or equal to 5. Those two conditions must be met in order to do this. So this is the condition that must be checked every single time you're running a one proportion z-test, because if the sample is not large enough, you cannot run this test. So let's start with the first example. A researcher claims that based on the information obtained from the Centers for Disease Control Prevention, 17% of young people ages 2 to 19 are obese. To test this claim, she randomly selected 200 people in that age category and found that 42 were obese. We are given an alpha, and we're asked to figure out what is going on. Is there enough evidence to reject the claim? So when they say enough evidence to reject the claim, you have to find out what is the original claim. So let's start with the null hypothesis and the alternative hypothesis. Notice that at this point, we're talking about percentile. Percentile is the proportion, PP, that's how you remember, percentile proportion. So in order for you to set up the null and alternative hypothesis, you must use the appropriate parameters. The parameter for the population proportion is P. So your null and alternative hypothesis must contain the letter P because you're inferencing about a population proportion. Now, within the problem, you should have the assumed population proportion. That's that 17%. The information is obtained from the Center for the Disease Control and Prevention. 17% of young people are obese. So the 17%, the young people that are obese, that's your quote-unquote success, and the 17% is the assumed proportion of this particular success. She randomly selects 200 people. So when 200 people are selected, you know that n is equal to 200. And she found that 42 were obese. So she found how many people said yes to your quote-unquote success. The alpha is given to you at 0.05, and the researcher claims that based on the information obtained from the census bureau, 17% of young people are obese. So nowhere within the problem do you see the word greater than or less than. If there is no such words, we must run a two-tailed test, so we must have a not equal to sign in the alternative hypothesis. So you stated your hypothesis, your null hypothesis, your alternative hypothesis. You stated the necessary statistics in order to run the test. You're giving me the x and the n. Please tell me the test that you're running. So in this case, we're running a 1 proportion z-test. And tell me whether it's a one-tailed or two-tailed test. The not equal to sign will tell you that. So it's a two-tailed. And we can go ahead and run this test now. Before we run the test, you must check the necessary conditions to be met in order to run this test. So find out what n times p is. So in this case, n is 200, p is 0.17. So you're going to take 200, multiply by 0.17, you're going to get 34. 34 is greater than 5, so we're good to go. Check the NQ. That's the 200 times the other 83%. Definitely larger than the 34. So it's the other 166 that said no. This is also greater than 5. These are the two conditions that might be somewhere in the vicinity of your paper in order for you to even continue with the test. So if you're looking at this on a calculator, go under stats. Go over to tests. Go over to 1 proportion z-test. That's what it's called. If you click on it, it's asking you what is the p naught. The p naught, the p sub 0, that's the original claim. That's your null hypothesis. You put 0.17. Under the x, they ask how many people said yes to your question and how many people did you ask. Under the on your next line, you can choose the two-tail, left tail, or right tail. In this case, we do choose a two-tail test, and we push calculate. What you need is you basically need to write down everything from the calculator. The z is 1.5, 0.5, so I'll put 1. The next little p, it's not a p, it's a p-value. So please make sure to label it correctly. Your calculator is mislabeling it according to our labeling. So the p-value is 0.13. You don't need the p-hat and you don't need the n unless you're asked for the p-hat. And the n you already have. At this point, the p-value get compared to an alpha if you're using a p-value approach. At this point, 0.13 compared to 0.05 is greater than. So if you have a greater than, if your p-value is greater than your alpha, that means that your tail is bigger. If you're going to draw this as a picture, this is a two-tailed test, so that 13 is split up into two tails of about 6.5% on each side. That's the picture. Now, on the alpha, let me actually not shade this. Let me just label it. So these are your tails that are presumed. Now, the alpha of 0.05, that means that you should have 2.5% on each side. And that's your critical region. There we go. There's your 2.5% on each side. So you can tell that this p-value falls in the body of the problem. So if this picture makes sense, use it. If it doesn't, you can stick to a p-value approach. You can also look up the critical value that corresponds to two-tail 0.05 and compare it to the critical value using a classical approach. What most people will find convenient is the calculator spits out a p-value. Might as well use it. At this point, you do not reject the null hypothesis because your p-value is greater. You are in the body of the problem, not in the tails. This must be a complete sentence, so write do not reject, and then either write null hypothesis using English or null hypothesis using mathematical symbols. And then you have to write down a sentence. Now what they're doing is there enough evidence to reject the claim? What we said is we do not reject the claim. We do not reject the null hypothesis. So we proved that this is it. We do not reject the null hypothesis. His claim is that 17% of young people are obese. So this was his claim. And is there enough evidence to reject the claim? No. With you can say at alpha of 0.05 level of significance, we did not find enough evidence to reject the claim that 17% of young people ages 2 to 19 are obese. The sentence is what I actually grade. That's a chunk of your points, along with all the other information that will tell me that you actually ran the right test. Let me do one more problem, and that should do it for 8-4. An attorney claims that more than 25% of all lawyers advertise. A random sample of 200 lawyers in a certain city showed that 63 has used some form of advertising. At alpha 0.05, is there enough evidence to support the attorney's claim? So let's start. Null hypothesis. This is a proportion. This is the claim of 25%. So you must have a p is equal to 0.25. And the alternative hypothesis now has the word more. And that's the claim. So the p has to be greater than 0.25. And that's the claim that he's trying to persuade or trying to prove. A random sample of 200. So you're given an n of 200. And a 63. So 63 said yes to your question. And I just want to underline this. Quote unquote, success. All lawyers advertise. So 25% of all lawyers advertise. Let me erase the all. Lawyers advertise. Okay, so state the null alternative hypothesis. Write down the name of the test that you're going to run. So this is a one proportion z-test. Make sure that you're able to run this test by checking the conditions NP and NQ. So let's do that. NP, I have 200 times 0.25. That's the 50 people, definitely greater than 5. and 200 times the other 75%, that's the other 150 people who said no. We can go ahead and run the test now. So stats, over to tests, down to 1 proportion z-test, and then write down all of the necessary information. 0.25 for your null hypothesis, 63 people who said yes out of 200, and now you have to choose a greater than sign because we are running a right tail test. If you calculate, you will see the z-test statistic, it's 2.12. You will see a p-value of 0.017, so just under 2%. And we know that alpha is given to us at 0.05, and this is definitely less than 0.05. So what we do is we reject the null hypothesis. If we reject the null hypothesis, I'm pointing right about here. If you reject the null hypothesis, you reject the statement p is equal to 0.25 in favor of the alternative hypothesis, which happens to be my claim. So we found enough evidence to support the claim that more than 25% of all lawyers advertise. That should do it for this problem. On the next video, I can show you how to do this on the calculator.